Hi Method students, in this video we're going to go through a couple of exam questions involving discrete random variables. This is at the end of the 13C notes, so let's get stuck into it. Question 8, and this one's from an exam 1, so it's a non-calculated question. It says the discrete random variable x has the probability distribution. Now remember, with these probability distribution tables, lowercase x is showing us the possible outcomes, so whatever this variable is, it can either have outcomes of -1, 0, 1 or 2. And then the second row is showing us the probability of each of those outcomes. So this particular distribution, well, the probability that we get a result of -1 is p squared, probability we get a result of 0 is p squared, and so on. And our job is to find the value of p. Now there's two key features with discrete random variable distributions. The first one is that each probability has got to be between 0 and 1. Now we don't know the value of p yet, but we know that whatever the value of p is, it has to ensure that these probabilities will all be between 0 and 1 inclusive. And the second condition is that the sum of the probabilities has to equal 1. And in this question, that's the key condition that we can use to actually solve for p, because we know that p squared plus p on 4 plus 4p plus 1 on 8, right? So the four probabilities individually must sum to 1. Right, so essentially our job is just to solve that equation for p, which if we had a calculator would be super easy. If not, we're just going to have to do it step by step. It's a quadratic equation. All right, we've got p squareds, we've got linear terms of p as well, and we've got a constant. So potentially this is one that we're going to have to sort of get everything to one side and factorize and solve. So let's have a see how it sort of plays out. First thing we can do, we can obviously add the two p's together, two p squared terms together, plus p on 4. Now I'm going to make that p on 4 into 2p over 8, because then I'll be able to add it with this 4p plus 1 over 8, it all still equals 1. And then we can say, well, instead of 2p squared, let's try to get this over 8 as well, and this would be 16p squared on 8. So we can kind of make everything over 8 and have 16p squared plus 2p plus 4p plus 1 all over 8. Right, so we already had these two terms over 8. This one we've just kind of done two things in one step here. We've thought of it as 16p squared over 8 and then added the three fractions together because they've got a common denominator. Equals 1. Can now multiply both sides by 8. We'll get this. Bring the 8 over the other side. 16p squared plus 2p. Should have fixed that up. Had that 2p and 4p next to each other, so we might as well add those together and make that a plus 6p. And then minus 7 equals 0. So you can see that even though this is a probability question, really, as soon as we recognize we just had to add the probabilities together and let it equal 1, this is now just actually solving a quadratic equation. And these come up quite a lot on exam 1. Often examiners want to know if you can solve a quadratic equation without the help of your calculator. Now, what we might do in this situation is often look for like a common factor, see if we could sort of or divide or multiply both sides of the equation by something to make the numbers a bit easier. But given that 7's a prime number, there's not much we can do in terms of that. The numbers look a bit tricky, so it might be one that we would have to, go to the quadratic formula. But let's just see if we can factorize it first, because if it's possible to factorize, that's usually going to be the easier method. So let's see. We know that with 16p squared, we've got a few options. We might have 16p and 1p, or 4p and 4p, or 8p and 2p. Let's try, and look, the more you look at these, the better you get at them and the more practiced you are, the better you'll be at seeing what it might be. Let's try 8p and 2p. Right, now with a -7 at the end, we know that the constant terms have got to be 1 and 7, but it's just a matter of where we're going to put them. So if we put the 1 here, well, we know that 8p times 1, so that's going to produce an 8p. So if we put the 7 here, then that 7 and 2p will multiply together, if you think about how this works if you were to expand these two brackets to get back to the expanded version. So with an 8p times 1 to get 8p, and 7 times 2p to get 14p, we should be able to get this to add up to 6p. It's positive 6, so we need the larger sort of product to be positive. So 7 times 2p to get positive 14p, so with a plus 7, 8p times -1 would give us -8p, and so 14p minus 8p, that should work, right? And you can expand that in your head to make sure that you can convince yourself that that would expand back to the expression that we had. And so with that, we can now say, well, therefore, 8p plus 7 equals 0, or 2p minus 1 equals 0. If 8p plus 7 equals 0, then p equals -7 on 8. And if 2p minus 1 equals 0, then p equals positive 1/2. Now, looking back at these values up here, we've got to think about, well, remember that p, or these probabilities, not p, but the probabilities, the overall probabilities, have got to be between 0 and 1 inclusive. And if p is -7/8, well, then this one here when we look at this one, well, that's going to be a negative number, right? Negative 7/8 divided by 4 still results in a negative number. So P cannot equal negative 7/8. Since P, from this probability, we can say that P has to be greater than or equal to 0. Okay, so P equals half is our solution. And with each of these, it's pretty sort of quick and easy to check that if P equals a half, we'll get positive probabilities. They'll all be less than 1. And I'm not going to show it in the video, but if you actually subbed it in and checked them and add them all together, they will actually add up to make 1. So our answer here, our final answer, is P equals a half. And obviously we want to make that nice and clear that that's our final answer. Okay, second exam question for this video, again from an exam 1. So a bit of practice working without the calculator here. 4 identical balls are numbered 1, 2, 3, and 4 and put into a box. A ball is randomly drawn from the box and not returned to the box. So that's like saying without replacement. We take the ball out and then we don't put it back. A second ball is then randomly drawn from the box. What is the probability that the first ball drawn is numbered 4 and the second ball drawn is numbered 1? All right, so we could sort of write that as PR, let's say 4, 1, just say it's 4 then 1. Well, let's think about it. To begin with, there's 4 identical balls numbered 1 to 4 in this box. So we've got, 1, 2, 3, 4. Imagine them all. Oops, can't see that. They're all sort of sitting there. Put your hand in, you can't see which one you're grabbing, and one of them is going to come out first. Well, the probability that the first one comes out as a 4 is going to be 1 in 4. And so that's the probability that we get a 4 to begin with, right? Then once that's gone, well, we're now left with 3 in there, because remember, we're not replacing it. And the probability that the second one we pick out would be a 1, well, that's just going to be 1 in 3. So because these are events happening sort of one after the other, it's very much like a tree diagram where we're, 1, 2, 3, 4, then 1, 2, 3, 4. I'm not going to draw the whole thing out, but we're essentially, working out the probability that we would choose the 4 first, then the 1 second, and that will be a quarter times a third, which is 1/12. Okay. That question there was worth 1 mark, so working wasn't necessarily required. We could get it from, this kind of picture where we're just sort of visualizing the actual situation. We could use a tree diagram. Whatever gets us to that right answer, for 1 mark, that's what we need to show is the correct answer. Okay. What is the probability that the sum of the numbers on the 2 balls is 5? All right, so there's going to be obviously a few different ways that can happen. We could get, well, let's think of combinations of numbers between 1 and 4 that add up to make 5. We could get 1, then 4, right? We could get a 2, oops, back in the wrong spot. Could get a 2, then a 3. We could get a 3, then a 2. Oh, I've done it again. Or we could get a 4 and a 1, right? And they're, given that we've only got the numbers 1, 2, 3, and 4 to work with, they're the 4 different ways, the only 4 different ways that we could get, the sum adding up to 5. Now, because each of these balls are identical, the probability that we worked out in the first question, which was the probability of getting a 4, then a 1, it's basically going to be the same probability for all the different combinations. So the probability of getting a 1, then a 4 would still be a quarter times a third, because you've got 1 in 4 chance of getting a 1, 1 in 3 chance of getting the 4 on the second drawing. Again, probability of getting a 2, then a 3, different numbers, but exact same probabilities, because it's the probability of getting a 2 first would be 1 in 4. The probability of getting a 3 second would be 1 in 3, because there's one number we want out of 3 remaining. So each of these are going to have the same probability of 1/12, right? So it's just 1/12 plus 1/12 plus 1/12, or you could write it as 1/12 times 4, which of course is 3/12, which is a quarter. Okay, so the probability of the sum of the numbers on the 2 balls being 5 is 1/4. Okay, then we get to this last bit. Given that the sum of the numbers on the 2 balls is 5, what is the probability that the second ball drawn is numbered 1? So again, as we often do with conditional probability, and that's what this is, it's conditional probability, because we know that one thing's happened and we're trying to work out the probability of something else also happening. So given that the sum of the numbers is 5, what's the probability the second ball drawn is 1? So we're essentially saying the probability that the second is a 1. Given that, we know that the sum equals 5, right? Now, that's equal to, remember, it's the probability of both of those things on top. So probability second equals 1 and sum equals 5. Excuse me, I'm writing getting a bit messy there. That's a 1. Divided by the probability that the sum equals 5. Okay, and this is a 2-mark question, so we do need to show some working out here. So this is a really easy way to do it, to just use the conditional probability formula. All right, so let's look at this top one. The probability that the second ball is a 1 and the sum is 5. Well, if the second one's a 1 and the sum has to equal 5, the only way that that top event can happen is if we get the 4 then 1, right? So we need to pick out a 4 and then a 1. The only way that that event can happen. And we've already worked out that probability, so that's great. So we can say, well, that's equal to probability of 4 then 1, right, on top, over. Now the probability that the sum is equal to 5, we just worked that out previously. Okay, so this question is actually building off our previous answer. We've already got the answer for the probability that the sum equals 5, and that is 1/4. And so on the bottom, we can actually put in 1/4. And so, get my working's getting a bit hard to follow. Probability of 4 then 1, well, we said that was 1/12. So actually we're just using our two previous answers, aren't we? So the probability of 4 then 1 is 1/12. The probability of the sum equaling 5, we already put that in as 1/4. So it's 1/4 over, sorry, it's 1/12 over 1/4, which we can write as a division so that we can then sort of tip and times. So this will be 1/12 times 4 over 1, which will just be 4 over 12, which of course is 1/3. Right, and if you've done some messy working like I have here, you know, and this is an exam or a SAC or something like that, really make your final answer nice and clear so that people don't have to go looking for it. You're showing clearly that your final answer is 1/3. And we've got some working, albeit a little bit messy, but some working to get the 2 marks. Because remember that with a 2-mark question, we need working and a final answer.